morning, students. In the last class, we had started atomic structure and we have seen how electron was discovered by J.J. Thomson. J.J. Thomson also measured that the deflection, the amount of deflection of these cathode rays depend upon certain factors. And therefore, we would calculate the value of E by N. We have stopped it here. So, this value E by N for an electron was coming up to 1.75 into 10 to the power 11 coulomb per kg. Miracle all-group experiment, and our scientist, he performed this experiment to calculate the charge of the electron. And this charge is coming up to electron is negatively charged. So 1.6 into 10 to the power minus 19 is the charge of an electron. And with the help of this charge, Thomson could calculate the mass of electron. And this value is coming up to 9.1, 10 to the power minus 31 kg. Okay, so these are the charge, value of charge of an electron. What is the mass of an electron? This data should be remembered by everyone. Okay, today we are going to start that how proton was discovered. Now, we know that atom is electrically neutral. So, if atom consists of a subatomic particle, that is electron, which is negatively charged, as concluded by J.J. Thomson, there was another scientist, Bernstein. He in 1990 modified the same experiment, that is cathode ray tube experiment. But what was his modification? He just changed the cathode and the anode. Okay, the position of the cathode and anode are changed, you can see, and here the cathode will have some perforation, that is hole. So, and the rest of the setup is same, you can see. So, what it did, he again connected the anode and the cathode with a high voltage source. The end of this tube was coated with the fluorescent material, and the pressure of the gas inside this discharge tube was comparatively little higher compared to the cathode ray experiment which Thomson did. Okay, so here the pressure of gas was taken as 0.1 millimeter of mercury. Means I can say the number of gas molecules here inside this discharge tube will be comparatively more as compared to the Thomson's experiment. Okay, so this was a setup, and when we saw that on connecting this anode and cathode with the high voltage source, this is the vacuum pump through which the pressure of the gas can be regulated. He saw that as cathode rays were generated from the cathode, in this simultaneously there was another ray which was generated from this anode, and they were moving towards the cathode, and because the cathode had a hole, so they passed this cathode and struck at this fluorescent material, causing this fluorescent material to illuminate. Okay, so the experiment is more or less same. Only the change is the position of the cathode and anode, and the pressure of the gas is comparatively high. So this was his experiment. What else did he do? If we change the gas, okay, instead of hydrogen, suppose now if we take helium gas, we saw that again anode rays are produced, they are causing the fluorescent screen to illuminate, but the particles of these anode rays are not same for helium gas. Okay, therefore, in Thomson experiment, whichever gas, whichever material of the electrode we were taking, they were giving us the same electron. Isn't it? Cathode rays were made of electron. But here remember, these anode rays, which is also called as canal rays, they are not subatomic particles. They are actually made up of proton. And what is a proton? You can understand hydrogen. This is the atom of an hydrogen. You know the hydrogen atom consists of one electron and one proton. So what happens is, if the proton is given away, what is there? I will get an H gas. H gas ion. That is a gaseous ion. This gaseous ion will have only one proton, and that is what is anode ray is made up of. So actually the anode ray causes the ionization of the gas. They are made of this charged, positively charged gaseous ions. Okay? And that is where, because they are positively charged, they will move towards the negative electron. Okay? So, what else was this observation? That if these anode rays were subjected to an electric field, as I have shown here, this is the negative plate, this is the positive plate. They would see that because these anode rays are made up of positively charged particles, so they were deflected towards the negative terminal. Or in other words, I will say these anode rays were deflected towards the negative plate. So therefore, he concluded that anode rays were actually made up of positively charged particles. Okay. Similarly, when he applied magnetic field, he saw that the deflection of these anode rays were in the opposite direction, which would be same as when any positively charged ray was subjected to a magnetic field. The direction was same. That it will move in this particular direction. Okay, this is the direction when I am applying magnetic field, and electric field direction was this one. So, by subjecting electric and magnetic field, it can further be concluded that these anode rays were made up of positively charged particles. Okay, so this is how he concluded that there is something else in an atom, and that is positively charged particle, which he named as proton. So, what were his observation and how did he conclude it? The first observation is it travels in a straight line. Okay, how? Again, the same thing which comes in it. That if we place any opaque object in the path of these anode rays, they would cast their shadow. So, this indicates that these anode rays also travel in straight line. And one more difference is these rays were colored rays. Okay, but the velocity of these anode rays were much smaller than those of the cathode rays. Then what is second observation? The rays are positively charged as indicated by their direction of deflection in presence of electric and magnetic field. Okay, you can add up in presence of electric and magnetic field. Third observation, they are stream of positive ions of the gas enclosed in the discharge tube. That is what I told you. If you look at helium, the mass of helium is 4, isn't it? So actually, then helium will have 2 protons. So you can understand that the helium ion plus 2 helium ion and hydrogen ion will not have the same mass. Okay, I did not have space here. So what are the other properties which I could write? That the fourth property I can write here, that they possess kinetic energy. Why I am saying they possess kinetic energy? Because I have understood that these are positively charged. These anode rays are made up of some positively charged particle, and particle will have some mass. Mass means kinetic energy half mv squared. Okay, so I can say they possess kinetic charge. Fifth property I can write down, they produce fluorescence. And the last property I will write down, that they can ionize the gas. Isn't it? This point is very important. They can ionize the gas. Okay, so remember the proton is actually, this anode rays will depend upon the nature of the gas, nature of the electrons also. Like electron was independent of the nature, cathode rays were independent of the nature of the gas and nature of the electrons. But anode rays will depend upon the nature of the gas enclosed in the discharge tube. Okay, so in this way, Goldstein concluded that atom also consists of a positively charged particle which he named as proton. Okay, and further Okay, so we can say that proton is approximately 1834 times the mass of an electron. Okay, so in this way he concluded that atom is also containing another positively charged subatomic particle. Next, we will see that how neutron was discovered. Okay. Okay. So next is discovery of neutron. Now, this was done by Chadwick, scientist Chadwick, in the year 1932. Now, actually, see how did Chadwick concluded that there is another subatomic particle. Okay, that is how did he discover a neutron? He, by this time actually, the number of protons present in an element, in different elements were calculated. So, what he did that if he, on one side of a balance, he actually kept an helium atom. Okay, and on the other side, he kept two hydrogen atoms. Because you know that hydrogen atom will have one proton and helium atom has two protons. So he suggested that it means that the weight of two hydrogen atoms should be equal to the weight of one helium atom. Isn't it? But when he kept these two, when he measured the value of two hydrogen atoms and the weight of one helium atom, he still found that the weight of helium atom was more as compared to the weight of two hydrogen atoms. That is, helium atom is still heavier. So he therefore concluded that there is something inside this helium atom which is actually responsible for increasing the mass, though it will not have any charge because proton and electron was already discovered. So he had already found it, already discovery was done, how many positively charged, that is proton, and how many neutrons are, how many electrons are there. But here he said that there is something which is contributing to the mass of this helium atom. Okay, so what it is did he, when he placed four hydrogen atoms on one side of the carpets, or he took the measure mass of four hydrogen atoms, he saw that the mass of four hydrogen atoms was equivalent to the mass of one helium atom. Okay, so we know that the mass of one helium atom is 4 MeV. Okay, so he therefore concluded that there is something neutral particle present in this atom which is contributing only to the mass. So what he did next is these are alpha particles. Okay, though the discovery of nucleus we will do later on, that was Rutherford's experiment. We are actually seeing how neutron was discovered. So what did Chadwick did? He actually subjected these alpha particles to a sheet Okay, this sheet is actually made of element. It can be element. Okay, he actually initially took lithium, boron, beryllium, these type of elements. And what is alpha particle? Alpha particle, you know, it is helium ion. That is H8 plus 2 ion is actually alpha particle. So when he subjected alpha particles to the sheet, he saw some radiations coming out of this sheet. Okay, and this radiation were comprising of some particles which had no charge, but the mass of these particles was almost same as Parafin sheet. So he concluded that these radiation actually contain some particles which whose mass is definitely greater than the mass of electron. If they consist of particles whose mass is very small, then they would not be so heavier that they could emit protons from you, isn't it? So he concluded that these radiations are actually made up of some heavier particles. That is why when they are subjected to a paraffin sheet, they can actually release the protons. Okay, so in this way, he concluded that an atom also has another particle which is neutron, whose charge is neutral, but mass is more or less same as proton. Okay, so this is how we actually concluded that atom has another subatomic particle, that is proton. Okay. So I hope you people have understood that how proton was discovered and how neutron was discovered. Okay, so finally the model which Thomson gave, that is plum pudding model, okay, that was no longer verified because number of positively charged and number of negatively charged, it says that the atom as a whole is neutral,